Hey guys, so this lesson's called 5-5 Rationalizing Denominators with Monomials. So what this lesson's about is like if you guys were to get some kind of fraction with a radical left in the bottom, that's called improper in math. Like you can't leave it that way. So what we do is we do what's called rationalizing a denominator. So if you have a single monomial term, meaning like a one term in the denominator, how you rationalize it is you just multiply the top and bottom by that radical, and that way it'll produce a perfect square in the bottom. I should say a perfect square radical in the bottom of the fraction, so it'll make it like a whole number. Okay, so I'm just going to work out a couple examples with you, but really quick before we start, all of these require, like the next 2 days of lessons require you to simplify in simplest radical form. So like as a really quick review, if I gave you like say square root of 20 and you had to simplify that, if you guys forgot how to do that from probably last year and when you did geometry with me, you break it up into two radicals, and our perfect squares are like 4, 9, 16, 25, 36, 49, 64, 81, 100, and it keeps going, right? Okay, so I try to find the largest perfect square that divides evenly into 20, and that's just going to be 4. 4 times 5 actually gives me 20, and then if I were to take the square root of 4, I just get 2. And that's how you can simplify square root of 20. So at the end, when you're doing all your simplifying, if you still have a radical that can be broken down like this, you guys still kind of have to break it down. Okay, so for example, number 1, you're going to multiply the top and bottom by radical 5 over radical 5. And that's going to give you 5 radical 5 all over. And radical 5 times radical 5 gives you radical 25. Okay, so if I simplify the bottom now, I have 5 radical 5 over a 5. And then these 5s actually cancel each other out to be 1. So your final answer for that first example ends up just being radical 5. Kind of cool. So a way to check your work is if you were to put this in your calculator and then, you know, your end result in the calculator, you should get the same answer. That's how you know you did it right. Okay. So for number 2, that one I would just multiply by square root of 2 over square root of 2. The top now is going to be square root of 6 times square root of 2 is square root of 12. The bottom is going to be 4 times a 1 technically. And then square root of 2 times square root of 2 is square root of 4. Okay. So then from there, you get square root of 12 all over 4 times 2, or that's just square root of 12 over 8. Now, the question says to put your answer in lowest form, so I can keep going because if I look back to my perfect squares, 4 fits into 12 evenly, right? So I can break that down into square root of 4, square root of 3. Right, those multiply to give you square root of 12. So I would have 2 square roots of 3 over 8. And then 2 8s in my calculator simplifies to be 1/4. And I still have that like radical 3 there. So I don't technically need that one in the front, but like my final answer would be radical 3 over 4. And then the last type of example is if they have something like this where there's the number in the front and then the fraction underneath the radical, you guys are going to split top and bottom, like split the radical up into 2 separate radicals with division, and then do the same process as like the previous problems. So this one, I mean, usually if say that was like radical, I don't know, 2, we would be multiplying by radical 2 over radical 2 and then simplify. But since radical 4 is actually already a perfect square, that's just going to give you 2. And then 6 divided by 2 is 3. So the final answer on this one is just 3 radical 3. Okay, and that's how pretty much all the homework goes. So the first few are going to look just like one. You have a couple looking like two, and I think I only had 2 examples that looked like 3. Okay, but make sure at the end, whatever radical you have left, there's no radical in the denominator, right? So I have no more fractions with it down below. And just make sure these radicals have been broken down as far as they can go. Okay, thanks guys.